Alrighty, guys, and so we're going to do hopefully maybe the last little bit of this series of videos. This we're going to talk about is the special cases you would find in energy. Hopefully it can help explain a couple of different things. One being is if an object is being pushed or pulled. I've noticed that every once in a while they like to trick you with what kind of system you're given. So what I'm going to do is I'm going to draw two boxes where one is going to be pushed inwards and the angle given is going to look a little bit differently. And so what does that look like exactly? And let's say, for example, this first one off on the left, I gave you this angle theta, and on the other one, I gave you this angle of theta. How does that change my trig when I'm trying to find my x direction of my force component? And I don't like using just the basic formula that's given on your reference sheet because not always is the default going to be cosine. It's a little bit of a trick there. So to find my force in the x direction here, if we say this is force applied or force of tension, what would, for this example on the left side, what would that look like? Well, force, if this is my angle, opposite over hypotenuse means sine theta equals fx over f, and that means force in the x direction equals force sine theta. Over here, if you're given a different angle, would say more respect to the horizontal, this is more respect to the vertical. If we say this is going to be adjacent over hypotenuse, you're going to say is cosine theta equals fx over force. And so you get fx equals force applied cosine of theta. So this is the reason why I don't get too used to using the formula that's given on your reference sheet, which is work equals force dot distance. I'll erase that real quick. Where it says, work equals force parallel dot distance, or force cosine force dot distance cosine of theta. And that's because not every single time you're given a energy question are you going to be using cosine. Sometimes you'll be using sine, sometimes you'll be cosine. So I don't want you to get in the habit of using that. Just use your trig triangle. Second thing I would like to point out is if an object is moving in a circle. So let me draw a little circle out here real quick for you. And if I have an object that moves in a complete circle, what is going on here exactly? If I go back to my pendulum example, instead of it moving back and forth, let's say my pendulum is, we'll call this in the horizontal, so the vertical direction, so I'm spinning this up and down, and I'm holding it by a string in the middle. Well, as the pendulum goes around the circle, we're going to notice at the top, all of the energy you've put into the system is potential energy. And what we haven't found out here is that if this pendulum then comes back down, your change in energy is 0 for one full rotation. If change in energy is 0, then that means your work is also going to be 0. Another thing that helps figure this out is that the force done here is perpendicular to your motion, and force dot, where work is force perpendicular to distance, that means work is still going to be 0 as well. Alright. As far as it comes to, I would say, this information and what's covered on your energy test, this is looking pretty good. As a wrap up overall, I am going to talk about the breakdown of the test. And so when it comes to, I would say, the three basics of AP Physics, The first one being kinematics, the second one being dynamics, and the third one being energy. This is all done right now, has been done in a linear sense. When it comes to the next couple units, particularly next semester, we're going to do this rotationally. And so what you run into there is you're still going to do kinematics, but it's going to be in a circle. And so this is often called circular motion, or circ motion for short. Dynamics is often going to be called circular forces or circular dynamics. And energy is going to turn into rotational energy. So the three units we've covered so far, you are going to see them pop up again when you have objects traveling in a circle. The other big unit to talk about that will transfer over into next unit will be momentum. Now momentum tends to be a little bit of a tricky unit, and so we'll call this, this is going to be angular momentum. Okay, so right here, this is 8 of our units when it comes to AP Physics. We really only study 10 units in total, and so this breaks down the majority of 7 or 8 of our units. Okay, well, that's going to be it for this series. I might add more later on as time goes on, or if I find some other special things to talk about. But good luck. If you have any questions, feel free to email me or shoot me a question in class.